Thanks everyone for joining us. My name is Avthar. I'm a developer advocate here at Timescale, and you are here for today's session on advanced tips and tricks for time series in Grafana. So this is the fourth and final session in our series on Guide to Grafana 101. So some of you may be here from the beginning, from session 1, where we started off focusing on how to build awesome visuals in Grafana. Session 2 was about getting started with alerting, and session 3, variables and templating. Today is the final session where we're going to tackle some of the advanced practices of dealing with time series data in Grafana. This is an interactive session, so please feel free to ask questions at any time using the Q&A feature in Zoom. So you'll see there's 2 buttons, one for Q&A and one for chat. Please use the Q&A feature for questions. If you just want to let us know what's on your mind, or if you want to respond to things, you can use the chat for that. But for questions, use the Q&A feature. And you can ask questions at any time, and our technical team of dashboarding experts are going to be on hand to answer them at the end of today's session. One other reminder that you will receive a recording of the session afterwards with code and links to resources and things like that. So if you want to share that with your teammates or go back and run through the session yourself, that'll be there for you to do. Okay, so before we get into the roadmap for today, I just want to do a quick introduction of myself, just so that we're not strangers. So my name is Avthar. I am a developer advocate at Timescale, originally from South Africa. One of the things I really like to do is to use technology to empower people. And so I'm glad I get to do that every day at my job as a developer advocate. I also write about the things that I learn and the new things that I'm learning every day, new technologies, on my website, avthar.com, as well as on Twitter. So if you want to give me a follow there, you're more than welcome to. So on to today's session. Today's session is going to be all about advanced tips and tricks for dealing with time series data in Grafana. So the session is broken down into 5 parts. So firstly, I'm just going to do a quick overview of the demo that we're going to run through. The demo is actually split into 3 parts. So part 1 of the demo is going to be about time shifting. How do we compare what's happening right now to previous intervals? That's the basic problem that time shifting is going to help us solve. The next thing is going to be automatically switching between different aggregations of our data. So say we might have a 1 hour, a 1 minute, and a 1 day aggregation. And I'm going to show you how you can actually automatically switch between all 3 of those in the same query so that you can get more efficient drill downs into your data. And then lastly, we're going to deal with this issue about templates and alerting. A lot of you may be familiar with Grafana's limitation of not having alerts on templated queries. I'm going to show you some different ways of how you can get around that. And then lastly, we'll leave you with some resources so that you can take what you learned today and apply it in your work and in your projects, as well as have some time for Q&A where we can answer your questions. So at any time, if you have any questions, please put them in the Q&A feature, and we'll definitely get to them at the end of the session today. Okay, now that we know where we're going, let's get started with the first part. Sorry, that's the wrong thing. Let's get started with the first part of the demo overview. So what exactly are we going to look at today? As already mentioned, the theme for today is advanced tips and tricks for handling time series data in Grafana. I'm going to show you a variety of how-tos as well as workarounds for situations that may have tripped you up in the past. And the reason why we wanted to do this session is because, once you've learned the basics of visuals and alerting and templating, there are still common issues that can be frustrating. And I'm going to show you how to overcome 3 of these in today's session. Okay, one other thing that I wanted to mention is if you are in need of brushing up on the basics, unfortunately, this is not the session for you. If you're looking for getting the basics of creating awesome visuals, alerting, and templating in variables, you can go to this link where you can find the previous 3 sessions that we did about the basics of Grafana. This session is really for more advanced and more nuanced problems that we're going to solve. If you're a beginner and you're looking to just get started with Grafana quickly, I'd recommend you check out these 3 sessions that we did previously on visuals, alerting, and templating. So that's just some expectation setting for today's session. And then going into the scenarios that we're going to use. So we always like to use real world scenarios and real world data sets when we illustrate anything here during our timescale technical sessions. So there's two scenarios that I'm going to use in order to show you the power of combining timescale and Grafana together. So the first one is around taxi ride monitoring. So this is a classic IoT use case where these vehicles have devices on it, and we can track the activity of the various taxi rides that are going on. And I'm going to use this use case to show you how to build time-shifted graphs, as well as to get efficient drill downs on your data where we automatically switch between different granularities of aggregations of your data. So that's the IoT use case. We're going to be using the taxi ride monitoring example. And then in scenario 2, I'm going to use a more classic DevOps scenario of microservice monitoring, where we're going to learn how to set up alerting on dashboards that have variables and templates. Okay, so that's the overview of the scenario today, IoT and DevOps, something for everyone, depending on what your use case might be. So let's get into the first part of the demo, which is building time-shifted graphs. So again, just a reminder, if you have any questions, please put them in the Q&A, hit the Q&A button and ask them, and I'll either answer them during the session or at the end. Okay, so let's dig into time-shifting. So as I mentioned, in this part of the demo, what we're going to do is learn how to create time-shifted graphs where we compare a metric, the value right now, to a previous time period. And this is going to be using Postgres and Grafana. Okay, so as I mentioned, the scenario that we're going to use for this and the data set that we're going to use for this is the New York City taxi rides. So this is data from January 2016. And basically what this does is we're going to be querying a data set that records the taxi ridership over a period of time. So in this case, over 1 month. And this data set also associates the time series data with metadata. Some of you may be familiar with this because this is a data set that we use in our Hello Timescale tutorial. If you want to play around with this more, you can check that out at the link on the screen, tsdb.co/timescale_taxi. So that's the use case, just to give an understanding of the underlying data. Basically, we're looking at taxi rides over time in New York City over the month of January 2016. Okay, now onto the problem of time shifting. The issue here that you might often run into in Grafana is, you want to compare activity of a metric at the current value, so activity of what's going on right now, with that value of the metric in a previous time period. So for example, you might want to know for something that happened today, what was the value at this time 1 day ago, 2 days ago, 3 days ago. So you're basically comparing an activity in period T with some activity in previous periods, T-1, T-2, etc. And we're actually going to learn how to build this exact graph where the goal that we want is to at any point in time be able to compare what's happening right now with what happened in the past super easily. And the two queries that I'm going to take you through today is how to compare today's rides with the prior 2 days of rides. So again, using our example of taxi rides. And then we also want to compare the rides that are taking place today to last week. So at any point in today, I want to be able to see the rides from the past 2 days, how that compares to the past 2 days, as well as how that compares to last week. So that's just some orientation for what we're going to see in a moment. So there's different ways to do this. And the first way to do it would just to create separate graphs. And you could have even have a graph for week 1 and week 2 and juxtapose them. But the issue with that is, it's kind of difficult to compare it side by side because these are two different graphs and you have to constantly kind of switch between them. And it also requires maintenance and manual updating. So it's not automatic. You're not actually you're not automatically setting the time periods. And so if you manually create separate graphs for each week, then this is a approach that can work, but it's kind of suboptimal. The approach that I'm going to show you today is using TimescaleDB and Postgres as the data source, and we're going to use this join lateral function that Postgres has in order to do time shifting really efficiently and effectively. And this approach has a bunch of things going for it. So the first one is that it makes it very easy to compare trends, because we'll have the trend lines on the same graph. So it's very easy at any point in time to actually see how does the activity today compare to the previous days or the previous time periods. So that's what we're going to show. And it also auto updates. You can set it such that you write this query once, and it for any as long as you have connection to your data source, you will always be able to see how you compare to previous weeks. So it actually saves you time in the long run. The only con is that it requires kind of a tricky query, but that's not really a con, because I'm actually going to show you how to do that right now in Grafana. Okay, so let's get into our Grafana dashboard. What I'm using right now is hosted Grafana on Timescale Cloud, and we have it connected to Postgres and basically connected to Timescale, which runs on Postgres as the data source. Okay, so what we're going to do now is just take you through the problem, and I'm going to show you the end state that we want to reach for each of these graphs, and then we're going to build it step by step. Okay, so the end state, so let me just zoom in on this one here. So this is a graph that shows the time shift for the past 3 days. And if I zoom in on a period of time, let's say this period of 2 days, let's get to calculate. I can see, given the different colors, how the activity of the rides today compares to the activity of the rides at the same time, 1 day, 2 days, and 3 days ago. And we have these nice colors that differentiate the different days that I'm looking at. And so that's the end state that we want to reach. Let's see how we can get there. So the first thing we're going to do is create a new panel. And let me actually move this panel into this row that I have here. So we're going to create a new panel. And as I mentioned, the data source that I'm using here is Timescale, which is an extension on top of Postgres. For those of you who are new to Timescale, it's a time series database that is built on top of Postgres that basically is Postgres for time series. So it combines the power of a relational database with the scale and the performance that you'd usually associate with a non-relational database or a NoSQL database. So we're going to select this Postgres data source, TimescaleDB. That's where all my taxi data is. And then I'm going to manually edit the query. So what I want here is I'm going to use this I'm going to use the Postgres lateral join function, and that's going to allow me to actually plot the graphs for these different time periods. So what I'm going to do is just paste the query in here. That did not work. I'm going to paste the query in here, and then we're going to run through it line by line. So this is can seem a very complex query at first, but let's run through it. So firstly, what I want to do here is just at the top, the topmost select statement is just naming the series, as well as at a high level selecting the time and the ride count from this subquery that we're going to where we're actually going to get the different ride values for the previous days. So what I'm going to do first is construct a graph that shows me comparing the rides that have taken place today to the rides that have taken place in the past 3 days. So the first thing we're going to do is select the time, the ride count, and then I'm going to just define exactly what to name my various series. So in this case, I've said, okay, when the step is 0, call it today. Otherwise, just call it minus the interval value and cast it as text. And we're going to call that metric. That basically just tells Grafana what to put in the legend down here. So as you can see, minus interval, we have -1 days, 2 days, 3 days. That's basically what that statement means. Then what we're going to do is the secret to this query is to use this join lateral function. And what does a join lateral function do for those of you who might not be familiar with it? Basically, these lateral joins are kind of like a for each loop in Postgres. So what it does is that it makes the results of the query before the lateral join. So in this case, what I'm doing is I have a subquery to generate the intervals. So I want an interval of 0 days, 1 day, 2 days, 3 days. It makes the results of this subquery available to the subquery after the join lateral statement right here. So essentially what's happening here is that I have a subquery to generate the intervals. So what I'm doing here is I'm selecting this thing called step, and the interval, I'm creating an interval, so a step day. And then I'm using the Postgres generate series function to say, okay, from 0 days to 3 days, give me each of those possible values. So the outcome of this is basically going to be 0, 1, 2, 3. I can then access each value that is returned from this subquery to create the intervals, such that I'm going to have a subquery to select the rides for that particular period of time. And so what I'm going to do here is I have another subquery. So I have a select statement, and I'm basically going to bucket the time that the rides took place into 15-minute intervals. And usually for when you're using time bucket, so for those of you who are not familiar with time bucket, it's a special SQL function in Timescale that allows you to bucket your data by arbitrary intervals. And so in this case, I'm using 15-minute intervals. And usually you'd have to specify the name of the time column. So my time column in this case is called pickup date time. But the trick here is to add the value of the interval. So interval is something that we defined up here. In this case, it'll be 0 days, 1 day, 2 days. You want to add the value of the interval, and it's going to do this for each value of the interval, each of these 0, 1, 2, 3. So that's what it's going to do. So we're going to cast that as a timestamp, and then we just want to select all the rides and call that ride count, and we're doing that from a hypertable called rides. And then what we're going to do is actually in our where clause, what we're going to do is subtract the value of the interval from the time to plot it. So for example, because we want all of these on the same graph, this is what actually allows us to get them all on the same graph, such that even though I'm looking at a time period for today, I can actually see the values from a day ago and 2 days ago and 3 days ago. And that's because of what we're going to cover now. So what I do here is that I say when the pickup date time is between the time. So in this case, we have the Grafana macro for time from. And what I'm going to do is I'm just going to subtract the interval from there. And again, from the time to subtract the interval from there. So for when the interval is 0 days, it's just going to be the time that's selected in the time pick at the top here. When the interval is 1 day, we're going to subtract 1 day from both the from and the to. 2 days, it's going to be subtracted from both the from and the to. And again, what that allows you to do is to have all these lines on the same graph, and to allow you to make this comparison such that at a point today, you can see the values from 2 days and 3 days ago. Because otherwise, if you didn't have this, it would actually be plotted. The values won't, you won't be able to do direct comparisons like we are able to here. And then lastly, we're just going to group by and order by 1, which in this case is the time. And then finally, because we're doing a lateral join in this case, so lateral join, we need to select something to join on. So I'm going to call this query L, and we're going to join on the values for which it's true. So what that means is that where we are able to compare both 1, 2, and 3 days, then you should only show those lines. I'm going to show you an example using the example of comparing 1 week ago, where you won't, because of the data range that we're dealing with, which is only 1 month in this case, you actually might not have, you might not be able to do comparisons because data doesn't exist for that time period. So on true basically means, whenever we have data that can show us the past 1, 2, and 3 days, plot the lines for that period of time. And then that's the query. And then I'm just gonna edit this panel title to say 3-day time shift, because that's what this is. And we're gonna save and exit. So you can see right now what we've done is just replicated this graph that shows the time shift for the past 3 days, such that at any point we can actually compare how the rides were doing to how the rides did 3 days ago. And again, this is something super useful, especially if you're doing analytics and want to know at a glance, how are you doing compared to your previous weeks or your previous days or previous months or even previous years. This allows you to see that straight away and allows you to separate upticks from seasonal things that are seasonal, where, at this time of year, you usually expect an increase, and allows you to separate variables that you might not have considered. So what I'm going to do here is just get rid of the full so that we just have the lines and so that it's a bit easier to read. Okay, so that's the first example, as I mentioned. So what we've done is we did this example of, here we go. We compared today's rides to the prior 2 days' rides. And now what I'm going to do is just compare the rides from today to the last week. And I'll show you how to modify the query that we have in order to do that. So essentially, what we want is to create this graph right here, which shows us the rides that have taken place today and compares that to 7 days ago. And in this case, we have 14 days ago, but I'm just going to do the one for 7 days ago. And as I mentioned, sometimes you might not have data that is able to be shown. So in the first week, because I only have data for 1 month, we can only see rides for today. And then after 1 week, I can then compare my rides for today for how the rides went 1 week ago. Whereas, in this first week, because I don't have data for the previous month, that's why I don't see this. But if you do have that data, then you won't experience this lack of data, or you won't just have one line on the graph. You'll have all 3 lines in this case. Okay, so this is the graph that we're going to create that time shifts by a week instead of a day. And I'm actually going to create another panel in order to create this. Okay, apologies, my mouse is acting really weird. So once again, selecting TimescaleDB as a data source, good old Postgres and Timescale. And then what I'm going to do is, again, I'll copy and paste this query in for you, and then we can go through it line by line. So the first part of the query is the same. It's basically defining, what the name is supposed to be. It's the exact same line of code that we had in the previous query. The only change here is that we actually change, instead of the interval being days, it's now going to be 1 week. So in this case, you can see in here, I am concatenating step with week instead of previously we were concatenating it with day. And because I only want data from the past week, so I want to compare how we're doing this week to last week, I'm only going to generate a series between 0 and 1. Obviously, as I mentioned, if I change this value to 2 and we let it refresh, I'll then compare it between 1 week ago and 2 weeks ago. So you can play around with the series that you generate in order to see how far back, how many intervals previously you want to compare to. And then we use the same trick of join lateral in this case. So we define the intervals that we want to compare to. So in this case, it's going to be 1 week ago. And then we do the same trick of adding that interval value to the time column. So we're going to be either looking at time from today or 1 week ago in this case. And then because we want all of these to show up on the same graph, the datetime needs to be between the time from minus the time interval and the time to minus the time interval. That's so that we can use the Grafana datetime picker here at the top and get accurate results. And then once again, group by and order by time, and then we're joining on true. And as I mentioned, if we select a time period that is more than a week, we can actually see where this join on true becomes important. Let's give Grafana a minute to refresh. I'm going to show you in a minute how to actually speed up Grafana so you don't have to wait too long for your queries to refresh. In the meantime, let me give this panel a title called 1 week time shift. And then we are good to go. Okay, so as you can see over here, the reason why we join on true is because, in this case, there's false values. We don't have values for 7 days previous to this because we only have 1 month's worth of data. Whereas once we do have that, we do actually get the values for the previous week so that we can compare them directly. Okay, and as I mentioned, this time shifting is super valuable if you're doing analysis and want to do comparative analysis really quickly. And it also tells us if our upticks or downticks are seasonal, or we can more readily judge if they're seasonal or if there's other variables that we might need to drill down into deeper. And so just as a summary of this section, we actually saw how to use lateral joins in order to do time shifting, in order to enable this easy comparison of your live data. So you can imagine the situation where data, this is actually a monitoring dashboard and you're looking at how many rides have taken place today at this point in time. And you can actually compare that very easily to at time periods in the past. So that's the power of time shifting, and that's how you can do it with Postgres and timescale. So that's demo 1 on time shifting. We're going to switch gears and go into demo 2 on automatically switching aggregations. But before we do that, if you have any questions about time shifting, things that we just saw, or want me to run through the query again, we can do that. Just one mention is that I'll be putting the code for the queries that I use on GitHub, and you'll get a link to the repo in the follow-up email that will allow you to take that code and then run with it and modify it for your own use. So, don't worry too much if you didn't understand every part of the syntax. You'll be able to play around with it yourself, or you can ask me a question and I'll explain a bit more. Okay. So now the second part of today's session is going to be about this idea of auto switching aggregations. So what is this all about? Essentially, the goal of, so what we're going to do in this part of the technical session is we want to be able to efficiently drill down into the data with fine granularity, and we want to do that really quickly. And so one of the best things to do in order to speed up your dashboards in Grafana, especially if you're using timescale and Postgres, is to not query the raw table or the raw data in the hypertable itself, but to use aggregations. And those aggregations are going to be on different granularities, so daily, hourly, minutely, depending on your needs. And so what we're going to show you today is how to automatically switch between these different granularity aggregations such that you can drill down most efficiently while getting the granularity that you want without consuming too much CPU power. Okay, so the basic solution to this would be to create graphs for each separate granularity, or to use the finest grain granularity for everything. And obviously this is easy, but the issue there is that you're going to have a bunch of graphs that show the same thing, just at different granularity levels, so it's duplicated. And then it also is CPU intensive and can slow down Grafana. And as we just saw, I was waiting there for about a minute for something to load. No one likes to wait for their dashboards to reload. So this is something that you can use in order to make sure that stuff like that doesn't happen. Okay, So let's get into the solution that we're going to be talking about, which is to use timescale and Postgres in order to switch the aggregate being queried by using Postgres union all feature, union all function rather. And as I mentioned, this is more CPU efficient, and you can actually get the fine-grained data only when you need it. And when you want to look at things at higher granularity, or you want to look at things at a more zoomed out perspective, you will then query less fine-grained granularity aggregates. And once again, the query can be kind of tricky at first, but I'm going to take you through it and show you exactly how to do it right now. Okay, so let's get back into our Grafana dashboard. Okay, all right. And as I mentioned, you could have a situation where in this case, I have two panels set up, one showing me, so they're both showing me the same thing. They're showing me the rides taking place in January 2016. One panel is using a daily aggregate. So I'm querying this aggregate called rides daily. So this is a continuous aggregate that I've created in TimescaleDB. And I have another panel that is showing me the exact same thing, but from an hourly aggregate, so rides hourly. And the issue here is, while I might have, say if I have something that I want to drill into on a specific day, if I zoom into that time period, I don't actually get the granularity that I'm looking for if I'm just looking at the daily rides. And then I have to go and switch over into my hourly rides, which gives me more fine-grained granularity. But I don't really want to have to do that switching. So let's see how we can make that happen. Let me just reset the time periods. And the ideal case is something like this, where you want something that at a high level, it shows you the daily number of rides that have taken place. So it shows you the general pattern. But when you want to drill down into the data, you can just select an arbitrary time period, and then you'll actually get more fine-grained data. So in this case, I'm seeing the hourly data. And then if I want to drill down even more, say to what's happening in this period here, I'm actually seeing minute by minute data. And in this case, what it's doing is switching between different aggregations of daily, hourly, and minutely. And we're going to see how to make that happen. Okay. So let me just, once again, change this time period. And we're going to create a new panel in order to see how to make this happen. Okay. So let's drag this panel down. Nope. Sorry, my mouse seems to be wrestling with me today. So what we're going to do is drag this panel down and edit. Okay. So now that we have this panel in place, we're going to select TimescaleDB once again as the data source. And now time for the query. So in this query, as I mentioned, we are going to use the union all function in Postgres. And let me show you the query, and then I'll explain exactly how that function works. Okay, now just selecting that query. And here it is. So at a high level, what we want to do is select values from all the different aggregates that we have. So I have a daily, an hourly, and then I'm just going to use the raw data for the minute levels. You could also have a minutely aggregate, but I just didn't set that up in this case in order to show you how to do it. And then what I want is when I'm querying data in a specific interval length, I want to use certain aggregations. So in this case, the rules that I've set up is I'm going to use daily aggregates for intervals greater than 14 days. Then I'm going to use hourly aggregates for intervals between 3 and 14 days. And then I'm going to use the raw data or the minute intervals for intervals between 0 and 3 days. So that's at a high level what we're trying to do. And so let's look at the code that makes that possible. So the first thing we're going to do, so this looks at minute. Let me actually zoom out. Okay, so the first thing that we're going to do is your basic select statement that selects the time and the ride count and the metrics. In this case, it says daily from this rides daily continuous aggregate that we created. And then we want to do is in the where clause, we want to say, okay, if the time from minus the time to is greater than 14 days, then use the time, basically use this time filter value of day. So this time filter, basically we need to give Grafana the time column in order to use such that it knows where to find the time values in order to plot on the graph. And in this case, we're saying, when the interval is greater than 14 days, we want to use the day time column here because we've selected time as the day here. Okay. Then what we want to do is, normally we create 3 separate graphs of these things. We have one daily, one hourly, one minutely. But the union all function allows us to just, as the name suggests, have the union of all these different queries. And then what we've done is, because we've specified where to use which time columns as Grafana's in Grafana's time filter macro, it'll then automatically switch based on the interval that we've selected which time column it's using. So we can see here again in the hourly aggregates, the first select statement is the same. We're just selecting hour as the time column, ride count, and hourly as a metric from the aggregate called rides hourly. And then here, where the time to minus the time from is between 3 and 14 days, the time filter time column is hour. So in this case, we have hour as the value that Grafana is using for the time filter. And then again, we're going to do one last union or query here. You can have an arbitrary amount of them. You can chain together all your different aggregation granularities. And here, I'm going to use the raw data from minute intervals. So between, for lengths between 0 and 3 days. And here, I'm just going to use a subquery because we're going to have a group by in here. And I don't want it to conflict by the overall order by time that we're going to do at the end. So over here again, because I haven't pre-aggregated them in time buckets, I'm going to use once again the timescale SQL function called timeBucket to aggregate things in 1 minute intervals, count the number of rides, and then select the minute as the metric that's going to show up at the bottom here. And then say, where when the time to minus the time from is less than 3 days, we want to use this pickup date time as the time filter. We're telling Grafana that, hey, this is the column that you need to use for the time filter. Then we're going to group by 1, which is time. So we're going to group these results by time and call this minute. And then lastly, order everything by 1. And so what does that get you? Let me just turn on the points so that we can see more clearly on the graph. And then I'm going to call this auto switching aggregations. So let's save this and see if that works. So what we've done is we can see here there's a time period that's the whole month. So here we have values every day of the month. And then if we zoom in to something that's less than 2 weeks, so let's say that amount of time, we have hours every hour, and notice how the metric has changed from daily to hourly. And then if we have, so let me actually put the query in view. If we have data that's more fine-grained than the 3 days, let's say just the 1 hour, then I can actually see minute by minute values. And again, the metric that's being shown here is minute. So it's easy as chaining together several queries with union all in order to get this automatic switching between different aggregates, as long as you define the time periods with which to use, or the intervals with which to use the different aggregates in this where clause right here. So over here, we said when it's greater than 14 days, use daily. When it's between 3 and 14, use hourly. And when it's less than 3 days, just use the minutely aggregates, which we've just done on the fly from the raw data. Okay, so that's actually how to solve this problem of making Grafana faster when you're doing these kinds of drill downs. And at the end of the day, what we saw is, let me just reset this time. What's tricky is that I'm actually, usually when you're using Grafana, you're using it for live data, but because my data is from 2016, this particular data set, I just have to reset the time all the time so that so I can see at a high level what's going on. So what we saw in this second part of the session is how to use the union all function to automatically switch between different aggregates. So the different aggregate views that we're querying, so that we can do more efficient drill downs at any, and get the most granular data at every level that we're looking at. And that actually makes Grafana much faster. Okay, so that brings us to the end of the second part of today's session. Now we're going to switch to the third and final part of the demo, which has to do with templates and alerting. So this part of the demo uses a data set that is a DevOps data set, and that's monitoring microservices in Kubernetes. And so at a high level, what's happening in this data set is that I'm scraping metrics using Prometheus, and I'm storing those metrics in TimescaleDB for long-term storage and analysis. And essentially, what metrics am I scraping? So I have all these different microservices that are consisting, that make up my shop. So for those of you who want to learn more about how this, the setup of this actually works, you can check out our Guide to Grafana templating session. We're actually going into more in depth about how I'm actually creating a template for a custom some microservice setup that I have, and I want to create templates to look at the different metrics that I have in 2 different shops composed of different microservices. Okay, so that's the overview for this session. So, but basically just know that I'm looking at metrics from Prometheus and they're getting stored in TimescaleDB. And the problem that we want to solve here, we want to look at how to work around, is that we can't actually use alerts on templated queries in Grafana. So I just put a screenshot of a GitHub issue that shows people are still asking for alerting support for queries using template variables. This has been open since like 2016. So this is a problem if you use Grafana before, or if you do decide to use the alerting functionality in it, you'll run into this sooner or later. And so what I want to do for you today is show you some ways to work around this limitation and explore the pros and cons of different approaches. We're going to look at 3 different approaches to be exact. Okay, so let's go into the first approach. So the first thing that you can try and do to overcome the inability to have alerts and templates together in Grafana is to separate your alerting dashboards and alerting panels from your exploration panels and dashboards. So you essentially create separate panels for each environment. So let's take a look at what that would look like. So let me just switch the Grafana environment that I'm in. So what I have right here is a templated dashboard. So let me just show you. I just have one metric that I'm looking at here, which is the max memory used by my Redis microservice. So this is a cache. And I have 2 different shops that are called Demo 1 and Demo 2. So if I select Demo 1, it'll show me the value, the max value for Demo 1. And I have another shop called Demo 2. It shows me the max value for Demo 2. And if I select all, it actually shows me the max value over both the shops. Okay, so that you can see that this dashboard is templated. If you want to actually see how to construct this query and how it works, you can check out the templating webinar that I did. But just to show you that this particular dashboard is actually templated. And the issue here, as I mentioned, is because I have a template, I get this error that template variables are not supported in alert queries in Grafana. So I have no option but to go back. And I'm trying to work around this. So option 1 is actually to create separate panels for monitoring. So what I've done is in this panel, I have this panel for exploration. And in this row, I have these 2 separate panels, one for the demo environment and one for environment demo 2, that I'm going to then put alert queries on. So because these are just normal queries, I've had to basically look at each of the environments that I have and create a separate panel for them. I can then actually create an alert on each of these ones, and alerts then function as normal. If you want to get into the nitty-gritty of how alerts actually work in Grafana, check out our second session on alerting in Grafana, where I actually take you through what all of this means. For the sake of time, I'm going to skip over that and assume that you already know how to use alerts. But if you're not sure, definitely go and check out that second webinar that we did on that. Okay, now as you can see over here, I have these two different panels and one for each environment. And so that's the first option that you can actually have, is to actually separate out your monitoring panels from your exploratory panels that you have here. Now, this option has some pros and cons, as with all of the approaches that we're going to see in this part. So the first one is that, it's a simpler implementation in the sense that it's conceptually simple to do, but and the other pro is that it's also easy to identify the values that are triggering the alert, because you have one panel for each value of the variable. So in this case, for each host, I have a separate panel. And so it's easy to identify the values that are triggering the alert, because you have an alert on each panel. And so if an alert gets fired, you know exactly the panel or the query that's generated that alert. The con here is probably the biggest con is just it requires so much work. There's so much of duplicate work that you have to do, as well as duplicate maintenance. So if you change something in your exploration dashboard, you got to change it in your alerting dashboard as well. And so that's the first one. And then secondly, it can just get really tedious. So in this case, as I mentioned, I only have two values that I have over here that this variable can take, demo and demo2, and then I have all. But what if you're dealing with a case where you actually have like 10 of these values, where you're monitoring, in this case, 10 different shops, or you have 10 different hosts, or just values that this variable can take? You're going to have to create 10 different one of these panels, and it's just going to be a lot of work to do it. And as I mentioned here, it can just get tedious if you're dealing with, let's say, more than 5 variable values. So that's the drawback for that approach. The second approach is something that one of the Grafana team members actually recommend themselves, is that you can actually use alert rules and turn them into something dynamic by using regex and wildcard queries. So it says the alert rules can already be made to be dynamic with regex and wildcard queries. So the next part of this exploration is to show you how to actually use wildcards and regex in your queries. So let's take a look at this. What I'm going to show you is a couple of approaches. So the first one is just using a general wildcard, and the second one, we're going to revisit our old friend, the lateral join in Postgres, in order to show you how to use that in order to get around this limitation of not being able to alert on template queries. Okay, so let's get back into our dashboard, close up this row, and open the second row for wildcards. So the only thing that I've done here is I still have the same query. Let me actually go to this query quickly so you can see what's going on. This is a SQL query. So despite these being Prometheus metrics, they're actually being stored in timescale, and I'm querying them using SQL. So all I'm doing here is that I'm selecting the values to be in 1-minute intervals, because I'm querying every 10 seconds or scraping every 10 seconds, and getting the maximum of this value because I want to know the max memory used. And in this case, because of the way that the data is set up, I'm querying a hypertable called Redis memory used bytes. So each of these metrics have their own table. And I'm doing a join on this Prometheus under a different schema called Prometheus series. And I'm doing a join to get the metadata associated with this metric of Redis memory used bytes. And part of the metadata is this Kubernetes namespace, which actually shows me the different, this is one namespace called demo, another namespace demo2. And in this case, what I'm doing is I just use this most basic wildcard, which is a % operator here, or the % character. And that basically says, okay, any of the namespaces, get me the values for them. So in this case, what this does is it essentially the same as using the all operator here. So over all the namespaces, it'll show me the value. But the drawback again here is that if I want to look at the values for each of the namespaces or for each of the values of the variables, I can't do it at least the way my query is structured right now. One way that I'll show you how to incorporate what we learned using lateral joins is you can actually use the lateral joins here in order to iterate over all of the environment names. So in this case, I've just selected the time, the value, and the environment as the metric. And then as we saw previously, lateral joins allow you to define things before the lateral join and have those things accessible to the query after the lateral join. So before the lateral join, I've defined a query just to get all the environment names. So I'm just selecting the namespace as env for environment from this namespace created hypertable, where the namespace is has the prefix demo. So in this case, I have demo and demo2, and I'm calling this genvs. So that's the query before the lateral join. And then after the lateral join, I have the same query that I used before, where I'm selecting the 1 minute intervals and the max value. And then the only difference here is that in my where clause, I have the namespace equal to env. So env is this variable that we've selected here as a namespace. And then for each value of env, it's going to generate a different line on the graph. So in this case, as you can see, demo and demo2, you have separate lines on the graph being generated, and we just close this up by joining on true. Okay, so that's how you can use lateral joins to get each of your different series showing up on the same graph. So each of your different values of your variable showing up. Let's look at the pros and cons of this approach. The pros is that, you know, this is easy to implement once you know about lateral joins. And it also shows you all the values of the different series in your alert notification. So in this case, as I mentioned, we have the different values. You have demo and demo2. And so because they're all different series on the same panel, you can actually get their values when an alert is triggered on that panel. So in this case, I can see demo has this value and demo2 has that value. But the con of this is that you can't actually see which of these series triggered the alert. It just tells you what the alert is and what the values of the series are. And you have to do the math, or you have to know the context in your head about, okay, what is the threshold value, and maybe go to Grafana to check that out. You could actually play around with the message that Grafana displays. So obviously this is a Slack alert. Most of the time you'll be receiving alerts in some third-party platform other than Grafana. But you could play around with the notification message that's sent in order to have the threshold value in the alert value here to overcome that. So the cons, as I mentioned, is you can see the values for each environment or value of the variable, but you can't immediately tell which one of the values caused the alert. Okay, and then option 3 is that we use something called hidden queries for alerting, and these are basically untemplated queries that you can use to then define alert rules on. So what I'm going to show you now is this third option. So wildcards we saw, and again, just to show you that we can actually have alerts on this, I can create an alert, and this functions like a regular query, even though I have different, I'm using wildcards in this case to mimic templating. And here under the hidden queries, in this case, what I have is I have 3 different series. I have the first one, which is actually a templated query, where I am using a variable name here. You can see the syntax to indicate a variable. And I have 2 of these other queries that are actually hidden. So you can see here, the icon over here is to disable and enable the query. So if I enable them, you can see them here, demo and demo2. But I've actually hidden these. And what these are is for each value of the variable, I've created a separate query. And now when I go to my alert panel, alert section of the settings, I can actually create an alert, but I need to take care of creating an alert on the panel with the right letter. So in this case, I can choose B and C, but not A, because my untemplated hidden queries are under query B and C, whereas my templated query is under A. So in this case, I can actually go under B and I don't get an error. I can select, I can put in a value here. But if I select A, I get this error that says template variables are not supported in alert query. So that's a way that you can overcome this by using these hidden queries, and you hide them so that, when you're doing your exploration, the graph still works as you'd expect it to. But when you're actually doing your alerting, you actually have these, you're able to have alerts on this graph. And again, the value of this is that it simplifies your operations pretty significantly because you have exploration and alerting in the same place. But the cons is that, again, your implementation time is quite a lot. You have to create one alert per you have to create one alert for every value of the variable that you have. And then you also only have one alert per panel. So this is actually something that's pretty important to notice, is that you can only create one alert per panel. So in this case, even though I have two queries that I want to alert on, I have query B in this case, where I'm gonna say, let's say the alert is above like 80 in this case, the value. And then where I can only have one alert per panel. So I have to have another query that says, or the average of the value in query C is above 80. And so again, the issue is going to become, it's going to be either query B is the one causing the alert or query C, but I don't actually know which one is causing the alert. And so even, when I define the alert message and stuff over here, I'm not going to know ahead of time. So I have to come back here and see exactly which value of the variable is causing the alert. And the restriction here is you can only have one alert per panel and not per query. And therefore you can't actually see which value of the variable is triggering alerts. Okay, so that actually brings us to the end of this part of the session and brings us to the end of the demo. Just as a quick reminder, we saw how to resolve the problem of not being able to query on to alert on templated queries in Grafana. We saw three different approaches. The first one was separating your exploration and your alerting. The second one was to use wildcards in your queries and using things like lateral joins to capture all the variable values. And the third one was to use hidden queries such that you can still alert and have your exploration in the same panel. So the recap of what we did today, we looked at three different things that are advanced practices for doing time series in Grafana. The first thing we saw is time shifting, which was a way to do comparison of what's going on in your system to previous time intervals in the same graph. The second thing we saw was how to do efficient drill downs by automatically switching between different aggregations of your data. And then lastly, I showed you some handy workarounds for how to set up alerts on your templated dashboards. So what's next for you? How can you actually take this knowledge and apply it to your own projects? The first thing I'd recommend is check out our advanced Grafana tutorials. You can do so at this link, and it'll also be sent to you in the follow-up email. So that then you can take the queries and you can take the things that I've talked about and apply them to your own projects. If you'd like to see the setup of the DevOps scenario that we actually used the timescale Prometheus adapter and Helm charts that gives you a 3-line installation of timescale, Grafana, and Prometheus in your Kubernetes cluster. You can do so at this link on our GitHub. The third thing is join the Timescale developer Slack. If you have any questions about timescale or how to use timescale with Grafana, there's people like myself, the Timescale co-founders, as well as other timescale engineers who are Grafana contributors, where you can get help and learn from other members of the community. And then if you're looking for the fastest way and the easiest way to get started with timescale, you can check out Timescale Cloud, and we're going to give you $300 in cloud credits to start off your evaluation. You can also use those cloud credits to finish the tutorial and to do other tutorials on Timescale if you just want to play around with it. And then lastly, share your feedback and ideas with us for webinars. We really put a lot of time and effort into these, and we want to make sure they're as valuable as they can possibly be. So if you have topic suggestions or things that we can improve, check out this link, tsdb.co/webinar-feedback. And then if you want to brush up on your Grafana basics and check out the 3 previous sessions that we did on Grafana, you can check out tsdb.co/timescale-webinars. And that'll take you to all the previous webinars that we did, including the Grafana ones. And then lastly, do join us for our next session that's going to be happening in August on 5 tips for improving your Postgres insert performance. So if you're using Postgres, we talked about today about how to use Grafana for visuals, but you need some way to get data into the database in the first place. So I'm going to be discussing some insert performance tips for you. The RSVP link will be in the follow-up email. Thank you so much for spending time with us today. We really do appreciate it, and we hope you've learned a lot. I'm going to make some time to take some questions. So if you have any questions about anything that we talked about or other Grafana questions that you were hoping to cover but we didn't, please put them in the Q&A right now and we can answer them.